All right, so here we're going to do our reflections about the axes. So this is kind of the last thing we have to kind of look at. We've looked at everything else up to this point, and so now about the axes. So this first one is about the x-axis, and what we have is we have a negative out in front. Okay, when we reflected about the x-axis. So our initial one is going to be, of course, f of x equals b to the x. And so when we get a negative b to the x, what happens is we're going to reflect across that x-axis. So whatever was going up now is actually going down. Okay. And so what happens, we have now instead of an intercept of 0, 1, now we have an intercept of 0, -1. Our range, instead of going from 0 to positive infinity, is going from negative infinity up to our 0. Okay. Domain, guess what? It doesn't change at all, and neither does our horizontal asymptote. It stays the same. Okay, so this one and this one stay the same if all we're doing is reflecting about the axis. Now, if we look here, this is our 2 to the x. So, we have our 0, 1, we go down 0, -1. And this was 2, 4. Now we're going to have 2, -4. And again, it's not exactly there, but, it looks like a bad drawn graph there. So, that's what we're getting. And our horizontal asymptote stays the same here. Now, what if we have b to the negative x? Now, initially b to the x, so now we're just taking a negative here. Well, that's going to reflect it about the y-axis. So we're going to go along this axis. So what happens? Well, we still are going to have our 0, 1 as our intercept, because if we reflect about that, well, you can't do anything, so it just stays right there. Okay. Now, what about our range? Well, our range is going to still be going from 0 to infinity, because all we're doing is just going back and forth across this, so nothing changes as far as up and down. Our domain stays the same as well, so we're good there. And our asymptote stays the same. All that happens is we go from over here, say 2, 4. Now we're going to go across 2 this way, and so we're going to be at a -2, 4. you know, and so maybe here we're at 1/2. Now it's gonna be -1/2. And so then we get our opposite over here across that mirror image across that vertical axis there. Okay, so that's going to be how it reflects across the y and the x-axis, depending on if we have the -b or b to the -x. All right, so find and graph the equation for the function g of x that reflects this about the y-axis. All right, so, well, if we want it about the y-axis, what's that going to be? Let's call it g of x. Well, that's going to be 1.25 to the -x, right? Because remember, if we're about the y-axis, all we're going to do is put a negative here, okay? So if we plug our f's in here, I don't know, let's do 0, 1, 2. So 0, 1.25 to the 0 is 1. 1.25 to the 1 is 1.25. And 1.25 squared is going to be, I don't know, so I'm going to plug that in my calculator. 1.25 squared, 1.5625. Okay. Now, what about our x for g? Okay, well, remember what we're happening. Let's kind of start plotting things here. So we have 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4. All right, so we didn't go up very high here. Maybe we should have done a bigger number. Maybe we should have done a 3. So let's do 1.25 to the third. And so that's going to give us a 1.953. Okay, so again, it doesn't really get too big. So we could have even done maybe a lot larger number, but then we're going to go way out here. And so what happens is it looks like this is going to be a very shallow growing thing. It's not going to be very big, okay? So now if we're going initially 0, 1, okay, well, that's going to be that point. 1, 1.25, maybe here. 2, 1.56, a little bit higher. And 3, we said is almost 2, so it's almost to here. And so again, it looks like it's very shallow. And this isn't going to be very good curve, but that's okay. So now we need to have something. We're going to reflect over here. So we know if we put in a 0 here, we're going to get 1 again. So let's just do that. And now if we put in here, when we reflect across here, that gives us a -1. And so if we plug in a -1, 1.25 to the -1 is 0.8. Okay. Oh, actually, 1.25 to the -1, 0.8. Okay. What about if we plug in, if this is here, huh. Oh, that's because now it's to a negative, so that actually is going to be a 1. So I'm already plugging in the negative. So we're kind of getting ahead of ourselves. I plugged it in how I wanted it. So if we plug in a 1, then it's to the -1, and so that's going to be a 0.8. So a 1.8 is going to what happens here, and so that would be actually this point here and the other one. So we're kind of have to make sure we're doing this right. And if we plug in 2 for x, what happens? Well, it's going to be 1.25 to the -2, and so that's going to be 0.64. Okay. And so now we have to start thinking, okay, that was 0.64. Now what if we put in a -2? So it's going to be -2, 1.25 to the +2. That gives us our 1.56. Okay, so we have to think about the opposite, and so this 1 is going to be over here around that point. Our 2 we just showed it was going to be at 1.56 at -2. That probably is going to disappear, and our 3 is going to be over here at -1 point that, and so what's going to be is, whoa, that's a very bumpy curve. Looks something like that. Okay. And so we really have to think we're plugging in a negative into that, and a negative is positive, and so then that's when we get this. So we kind of plugged in a few extra, but that's going to be how it looks like, because when we did the 1 here, it's going to be on the right side, and then when we plug in the negatives, then it's going to give us the left side. All right. So that's what I would do for that one. And again, I could plot the first curve and then just take points over across the y-axis and get the second curve just as easy as if I actually plotted those points. All right, so here it says, write the equation for the function described below. Give the horizontal asymptote, the domain, and the range. All right, so we're going to start with e to the x. Okay, so f of x is equal to e to the x. And we want to compress it vertically by a factor of 1/3. Okay, well, that gives us, and I'm just going to say maybe, we're doing this in order. So this is our original. Now part 2 is going to be compressing it by a third. So that's going to give us 1/3 of that. So it's going to push it down. And then it's going to be reflected across the x-axis. So 3 f of x is going to be reflected across the x-axis. So it's going to become a -1/3 e to the x. And then the last one says shifted down 2 units. All right, so that's f of x equals -1/3 e to the x. Down 2 units, -2. Okay, so that is the final thing. And I just kind of did it step by step by step so I could follow along what we were doing as we went down. Okay. And so that would be my final graph. Now, what do we know about the domain, range, and asymptote? So the domain, our range, and our asymptote. Well, y is going to be equal to what? Well, when we go down -2, that's going to be our new asymptote. Our range is going to start at a -infinity because we flipped it across the x-axis. So what we had our, our e to the x initially. Then we flipped it across. Well, then we compressed it, and then we flipped it over the axis, and then we shifted it down. Okay, and so we said that that y equals -2 was our new asymptote. So that means our range is going from -infinity to up that -2. And our domain, well, guess what? It stays our -infinity to +infinity. So that's kind of going to be our last graph looking thing. And it's again not drawn well, but what we did, we know we started our e of x, we shrunk it down by a third, then we flipped it over the axis, came that way, and then we shifted it down 2 units, and so that's where it would be. Okay, so that's our equation, and that's our 3 important items that they asked for there. Okay, it didn't say to graph it, but that's kind of the how we would graph it. You know, we do all the things as we move through. All right, so that's all I have for this section, so hopefully that will help.